Hey class, welcome back to our final set of notes here in Unit 4, Land and Water Use. Today we'll be discussing the topics of public and urban land use, so urbanization and methods to reduce runoff, as well as the next section on mining and impacts of mining. To begin with, we'll take a look at land use categories. We started off looking at this stuff and kind of hit each one of these types of land use as we went throughout this unit. So this is overall big picture. Understand that 42% of land in the United States is considered public land. This designation of public land splits into different classifications based on type and use. So rangelands for grazing, national forests, national parks as preserved areas. National forests include some forestry and logging. Wildlife refuges, which tend to be preservation areas, and in similar aspect, wilderness areas as well. 95% of these lands are managed by government agencies. So we just have 4 major government agencies that you need to know and kind of how they manage those things. So the BLM is the Bureau of Land Management, primarily responsible for managing grazing, preventing overgrazing, and land use in the rangelands out west. They do other things, mining, timber, recreation as well. There's some overlap between these other agencies. The U.S. Forest Service is another one that manages timber and logging, as well as recreational permits, things like camping, hiking, and grazing activities as well on that land. The National Park Service tends to be recreation conservation, so managing our national parks. And then Fish and Wildlife Services, conservation, hunting, and other recreation activities as well. To see really our breakdown of public land use, this is very similar to the map that we have in our notes, which shows us that grazing land is the largest component of land use, and then urban life is one of the smaller ones. Cities, suburbs. But ultimately, this is the fastest growing sector of U.S. land use in terms of increasing demand and resources. So why is there an increasing demand and resources in urban and residential land use? It has to do with a population shift that's really occurring as a trend and has been occurring as a trend for a while in the United States, as this urban-suburban sprawl. Essentially, the population's shifting away from these high-density, city centers to expanding suburban areas. So they're still in major metropolitan areas, so city growth tends to be higher in terms of metropolitan area, even though it may not be in the downtown city centers. What that does is it creates a shift to expanding suburbs, which reduces the amount of rural land that's available there. So we see this population shift. As a result of this, we see something like this positive feedback loop that's occurring here, is that if we have more people commuting in and out of the city, they're driving longer, so they're going to use more fossil fuels, which is more greenhouse gas emitted. Gasoline revenues tend to decrease. We get more highway construction occurring to accommodate for the increasing number of commuters. Congestion, longer commute times, there's more gas used, right? Because you're sitting in traffic, idling your engine. And so we see this happen as a trend with expanding suburbs. Now, people are doing this because the suburban life is cheaper. They tend to not like to be crowded, living in expensive apartments on top of each other. So having land and the ability to spread out is desirable for many people. Issues with this kind of positive feedback loop tend to be this downtown city center area needs more infrastructure to accommodate people who no longer live there, but they work there. So now they have less tax revenues from these people who used to live there. They used to collect tax money from them, and now they can't. So those suburban areas are receiving the tax money. And in reality, a lot of the financial burden occurs in the urban centers who have to now accommodate increasing cost with less input of revenue from tax money. It also affects a decrease in the valuable productive farmland that occurs in the rural communities as the suburban areas spread out and sprawl out. Oftentimes they're popping up in former agricultural areas, and because there's plenty of land and room there, which decreases agricultural productivity. How does urbanization impact us? What are some things that happen? There's kind of a unique impact here as urbanization ultimately results from this saltwater intrusion, which we'll discuss here. But ultimately, resources is the big one, right? More urbanization is increasing demand for resources, things like water and fossil fuels in particular, as well as increasing waste disposal and landfills. So we'll kind of hit on those. The first one, increasing demand for water. We are going to take more water out of aquifers. You can see in this picture here, we have this well pumping fresh water out of an aquifer. Now this is a unique situation called saltwater intrusion, which is near a saltwater body like an ocean and a freshwater aquifer. So what ends up happening with saltwater intrusion with these typical wells is there's a full aquifer, and that full aquifer is preventing this mixing of the fresh and salt water. As we pump, right, or as sea level rise continues, or as we continue to overdraw this, whatever happens here, this aquifer is going to be infiltrated with a higher concentration of salt water, and that salt water gets into your fresh water supply, which depletes the available freshwater resource, which we are depending on in that aquifer. So the overdrawing or overpumping of aquifers can do that in addition to just plain sea level rise. We also have impacts of the carbon cycle as landfills, more waste, more landfills, more methane is being produced. So we have greenhouse gases generated there and fossil fuels increasing use as more CO2. Reducing urban runoff. How do we prevent some of these urban issues in terms of the environment? Permeable pavement is one. So when we talk about putting more concrete down, this is impervious surfaces which don't allow the water to recharge in these aquifers. So using something like permeable pavement allows the water to percolate through into the aquifers below and prevents a lot of this runoff. Afforestation, just good old-fashioned planting trees. Obviously, we should be strategic in types and methods and how to do that to build sustainable forestry in our urban areas. But the more forests that we can regenerate, the better. Something like rain gardens, preventing runoff. If you've seen things like this in medians, I have some of these by my house. They take the water runoff down into these channels, and instead of dumping them straight down into storm drains, there are these rain garden strips that allow the water to be absorbed into soil and have specifically planted plants here to deal with the high amount of water runoff here before anything gets into a storm drain or sewer, and acts as a bit of a filtration and recharge capacity here. Something like a green roof is a similar concept. So instead of just having your standard roof on a building, just creating a green roof, which can hold on to water and support vegetation and trees and plants and gardens and take advantage of the space. And then building up, not out, so preventing the suburban sprawl as providing more housing in a vertical direction so that there's just less surface that is in concrete and buildings. The final section here is on mining. This really impacts of mining overall and some different types. So just some mining vocabulary is one of the harder things to get down here, but we talk about the goal of mining is to get ore extracted from reserves in the Earth's crust. So the ore is the stuff we want to get. It's the concentrated accumulation of these minerals. The reserve is really how much is available that can be extracted, this valuable, economically valuable amount of something that's underground. So ores are not renewable resources, and reserves are not evenly distributed. So mining is a challenge because once you exhaust a supply or you can't find it reliably, the mine is no longer productive. It's no longer economically beneficial. And restoring the ecosystem to what it was prior is likely not possible. Although the attempts are made, it's just not going to be the same. So easy access to ores tends to be the first thing, right? What's easier and cheaper to get to? Surface mining techniques, which we'll get into. Those are being depleted. So harder to access ores and lower quality ores are things that you'll be forced into finding, which creates a more dangerous scenario for humans anyway, as subsurface mining is digging deeper. So here's our mining methods. Surface mining removes excess soil and rock to gain access to the ore below, and we're going to go over 4 here real quick. So these are all surface mining methods. So you have strip mining, which cuts kind of into specific sections or layers and kind of just extracts like a single strip in an area. Open pit mining, which digs down and usually creates little roads to continue to dig down into these pits deeper and deeper for ore, and the pit kind of expands out to gain easier access to what's down below. Mountaintop removal is exactly what it sounds like, blowing up and extracting sections of the tops of mountains and kind of leveling them off as you go down looking for ore. And then placer mining is kind of panning through the water for specific valuable minerals, like here, like a river, like old-timey gold mining. And then subsurface mining is digging vertical shafts, like those deep coal mines, which you may have seen in movies, where they dig way down. There's an elevator shaft to get down to the bottom, and then the valuable ore is extracted that way. The consequences of mining, there's a lot here, but basically during construction and mining process, and then we're going to look at the processing of ore down here for number 2. So during construction and mining, what are some things that happen? Well, we have overburden, which we discussed. There's a big pile of rock left behind. So that's not going to be productive soil for an ecosystem or anything at that point. It's just a big old pile of non-biodiverse rock that's been extracted. Habitats are destroyed in the process of creating a mine and mining, building roads and digging the mine itself. And then we have human health impacts, death and respiratory illness, specifically in subsurface mining. That can be a really big issue. We also have something that's new called acid mine drainage, which is basically when a mine is opened or even left behind, materials that were underground or minerals that were underground are now exposed to things like heavy rainfall. So something like sulfur, which was underground, is now kind of kicked up, and the rainwater mixes through it and creates this acid mine drainage, which creates this really acidic water that runs off into the watersheds, into aquifers, into lakes, rivers, streams, and causes issues with biodiversity for sure by changing the pH and decreasing it. And also groundwater contamination. Air quality from digging the mine just kicks up a lot of particulates. There are dirt roads, big heavy machinery, kicking up particulates like dust and sand and soot into the air. When we process the ore, the minerals that are separated from the ore, once they do that, there's a little bit of waste rock there called tailings. And then just rock removed to gain access to the ore is called slag. So these are waste products that are, again, left behind at these mines that need to be dealt with. Benefits of mining, obviously energy dense, low cost coal provides cheaper electricity, which we've relied on for many, many years. Mining material like uranium can create, greenhouse gas free emissions and energy from nuclear power. And mining materials like coltan are needed for nearly all electronic devices, which we enjoy and also help us to be, technologically more productive in the way we go about life.